Hello, welcome to composition of functions. So right off the bat, I want to make sure I clear this up because when I set this problem up, when I wrote it, the software didn't allow me to do certain symbols. So I want to make sure I point out the fact that this can be written another way. So you can write it in this way when you carry out your instructions for composition of functions. You can write it this way, or you can write it this way. And these two things mean the exact same thing. They look different, but they have the exact same meaning. So like in math, you can have an X, you can have a dot, you can have parentheses right next to each other, and they all signify multiplication. So math is just one of those things that, yeah, we write different things with different symbols, but it all means the same thing. So try not to get confused. And yeah, if you just be flexible with the way that you digest information, then you won't think that everything is set in stone just because it's written one way and it can't be written any other way possible. So yeah, just try to get that misconception out of your brain, and yeah, you'll easily adapt to the fact that, yeah, we can write math in many different ways and it's going to mean the exact same thing. Okay, so whether we write it this way on the top or whether we write it that way on the bottom, it pretty much means the same thing. We do the same exact instructions, which means grab h, which is x squared, yeah, minus 3x. We're going to grab it. Right? How come it's not drawing a circle? So we're going to grab this. Yeah, we're going to grab h, which is that blue circle right now, and we're going to plug it into g. So when I plug it in, I'm going to replace the x that g has, and I'm going to plug in x squared minus 3x. So some teachers, they teach you this way, yeah, where they tell you, okay, so since h is known as something else, you can rewrite your equation to look like this. So some students, they like to see it this way because then it tells them what exactly is being plugged into g. We're going to grab x squared minus 3x and we're going to plug it into the g function. Okay, and that basically means we're going to replace the x and write x squared minus 3x instead. So let's do that. Okay, so we can continue this statement that we have right here, and we're going to go and we're going to write x squared minus 3x in place of the x, followed by the 5. Okay, so this entire thing right here, yeah, so you see that entire thing? He used to be known as x, yeah, but we're going to replace it with x squared minus 3x, but it used to be x, yeah, so we're just going to plug in one function into another. Okay, and then after that, we're going to see if we can combine like terms. And are there any like terms at all in this line of terms right here? So x squared minus 3x plus 5. Is there anything that I can combine together? And if there isn't, then I'm going to leave it as is. And we're going to be done with this problem. Okay, so that was kind of simple as far as what's happening. So let's go into something a little bit more complex. I mean, not that much more complex, but something a little bit is going to have more steps, I guess. Okay, so this one we can write it this way also. So some of your problems, your worksheets, your textbooks will have it written like this instead. And this means the exact same thing as the statement up above. Okay, and if you want to rewrite this as g of 4x minus 5, that's also an option that you have as well. Okay, so basically it means you're going to grab this 4x minus 5, which is our h, and we're going to put it right there. But the only thing that's different is we have x squared this time. So since we have x squared, we're not just going to write 4x minus 5 one time like we did the last time, right? Last time we just put one of them. We just wrote it one time. Okay, this time we're going to write 4x minus 5 twice because it has to replace x squared. So that means it's two x's that we're going to replace, right? There's an x here and there's an x there. So the 4x minus 5 replaces both of those x's. That forms x squared in our original problem. Then followed it up with minus 2. Okay, so this is the x squared right here that we broke into two pieces, x here, x there. And each of them get replaced, right, with the 4x minus 5. Okay, so then we're just going to continue with foiling. Yeah, so I hope you guys remember your foiling. So it's going to be basically 4x times these two things and negative 5 times these two things. Yeah, that's FOILing. Okay, so let's continue with this process. So we get 4x times 4x, and then plus 4x times negative 5. Oops, forgot the parentheses. Okay, and then now we're going to have plus again, negative 5 times 4x, and negative 5 times negative 5. So notice how, like I did in the previous problems and previous videos, yeah, whenever I separated the two sets of parentheses that were multiplying to each other, I always put plus signs. Yeah, I always put plus signs between the two sets of parentheses that were multiplying. Okay, so when we start multiplying it out, we can deal with the signs at that time. Yeah, so this is going to be 16x squared. Yeah, then this is going to be negative 20x. This is also going to be negative 20x. And this is going to be positive 25 and negative 2. So now we're going to do combined like terms. So these guys are like terms because they all have the single x. And these guys are like terms because these are your regular numbers, the ones that don't have letters attached to it at all. Okay, so we got 16x squared minus 40x, because that's what negative 20 and negative 20 make. They make negative 40, and then plus 23. Okay, and this problem's all done. All right, so good luck with this, and yeah, I'll see you in the next lesson. Goodbye.